Okay, final question of the paper. It looks pretty horrendous. We're asked to show that these three things multiplied can be simplified to this, where these are just integers. So we've got something like, 4w plus 7 over whatever it is. So that's basically what this bit means. Now, some people, when I was marking the paper, we're trying to actually work all this out, and we're doing that times that. You have to do 2w times w, then 2w times 5, and do this bit like expanding brackets, and same for this. And you're going to end up with very, very complicated working, and then you've got to multiply by all of this just to make it worse. This really isn't the right way to go about it. What you should really recognise is the fact that you've got w squared minus 25, and this is the difference of two squares, which you should know factorises really easily. But you can also see this factorises, this will probably factorise, and that probably will factorise. So really we need to factorise it, then we can cancel it down, and then we can try and simplify it to get into this form. So that's essentially what our method is going to be. So I'm going to start off now for this bit as well. I'm going to just focus on the first part here. If I did, for example, 3 times 4 times 5, that answer there would be exactly the same as if I did 3 times 4, worked out what that was, and then times it by 5 later on. So, what I'm trying to show you is the fact that, it doesn't matter if we just do this first bit first, and then multiply it by that, we still get the final answer correct, and it just means that it's a little bit more straightforward when we're trying to work this out. So we're going to focus on the first two parts. Factorise the top, so get 2w plus 4, that works, and then on the bottom we should instantly recognise the difference of two squares, so that goes into two brackets. We have w and w, and the square root of 25 is 5. So the trick is that this is going to be plus 5 and this is going to be minus 5, like that. Okay, so you might need to revise difference of two squares if this isn't familiar to you. And we're going to multiply it by this bit. Now the top won't factorise, but the bottom probably will. So when I'm factorising this, I'm looking for two numbers that multiply to make 2, but they have to add to make 3. So I'm going to look at 1 times 2, or the other combination that can multiply to make 2 is 2 times 1, which is exactly the same, so I don't bother repeating myself. That's what I'm going to use. I want it to be plus 3, so I need to have plus 1 plus 2, because positive 1 add 2 makes plus 3. If I have different signs here, it's not going to make plus 3. So again, I'm going to open up my two brackets, write w and w. It needs to be plus 1 and plus 2. That's what I'm going to write inside, and we can just expand it out in your head just to make sure it's correct. So we get w squared plus 2w plus another w, so 2w plus 1w is 3w, and then 1 times 2 is 2. So I get w squared plus 3w plus 2, which is what I wanted. So I know that's right. And also what you should now recognise is the fact that this part can cancel with this part, and also this part can cancel with this part. Now if you're not very comfortable with that, I can show you an example of why this works. So for example, if we had 3 quarters, and I'm multiplying it by, say, 12 over 18, okay, now I could do 3 times 12, let's give 36, and 4 times 18, which is 72, and then I can see that that will simplify to a half. So I could do it that way round, but really I don't want to have to do that here, because I'm using algebra, and doing that times that just makes things more complicated. Okay, so the trick is that if you're multiplying fractions, you can look at the numbers opposite, and you can see if you can cancel them down. Okay, sometimes you can cancel one side but not the other, but that's fine. In this example I can cancel both ways. So for example, 3 and 18, both of those will divide by 3. So 3 divides by 3, and I get 1. 18 divides by 3, and I get 6. Going the other way round, 4 goes into 4 once, and it goes into 12 3 times. So, you know, if you're multiplying fractions, you can use this trick. Have a look at the sides opposite and see whether they will cancel. And what this means is that if I now multiply this, it makes my life a lot easier, because 1 times 3 is 3, and 1 times 6 is 6, and I can now easily see that that simplifies to a half. So I'm dealing with much smaller numbers, much easier numbers than what I had when I didn't do it that way round. So that's why this works. I'm looking at the opposite sides, and I can see that we've got you know, w plus 2 and w minus 2. So effectively, when I'm cancelling across, I'm dividing by w plus 2. Okay, and the same way this way round, I'm dividing by w plus 5. So if I now just write down what I've got left, I've got 2 times, well, nothing, so I get you know, 2 on its own, and actually no, let's not think of it like that. Let's do 2 over w minus 5. Okay, so that's just what I've got left, because I've cancelled that bit, so I've got 2 over w minus 5, and I'm multiplying that by, that's now nothing. Now, it's not really nothing, because if I do w plus 5 and I've divided it by w plus 5, a number divided by itself is 1. Like 5 divided by 5 is 1. So that's really just 1. So it becomes 1 over w plus 1. Okay, and you know, I could just rewrite this as 2, and these two multiplied I could write as w minus 5 w plus 1. So I've just simplified that down. Okay, now this isn't my answer at all, because obviously I have completely ignored this bit, so I need to then multiply this by that. Now I want to factorise this, because I don't really want to have to deal with this. I want to hopefully find things that will cancel with this as well. So if we are factorising something that has a number bigger than 1 in front of the term squared, we need to times it by the number on its own. So 3 times 5 is 15. So I'm looking for two numbers that multiply to make 15, but they have to add to make 16. Okay, so again I'm looking for ways of making 15. I'm going to do 1 times 15, 3 times 5, and so on. And what's going to make 16 is using the 1 and the 1 and the 15. I actually want minus 16, not 16. So I'm going to have minus 1 minus 15, because minus 1 take away 15 is minus 16. Now, the way I teach factorising this is what I want to factorise. I'm going to rewrite this bit as in terms of 1 and 15. Okay, and I'm going to write 15 first. I'll explain in a minute why. So I'm going to write 3w squared minus 15w minus 1w plus 5. So the minus 15 and the minus 1 has come from the fact that I've identified that minus 1 and minus 15 will work to give me minus 16. By writing it in this form, this bit is exactly the same as that bit, so these are both equivalent statements, but by writing it in 4 parts, it helps me with my trick that I'm now going to show you. So if I split it in half, I can factorise each side. So on the left hand side of this, so we include this 15w here, I've got 5w on the outside, not 5, sorry, 3w, and in my brackets I'm going to put w, and then minus 5. Let's just check this works. So 3w times w is 3w squared, 3w times minus 5 will give me minus 15w. Now the trick is that this bit should also be on this side as well, so I'm going to copy that in, and I need to have a number here, so it needs to be minus 1 when I expand it out, so minus 1w, so something times w gives me minus 1, so this has to be minus 1 here, so minus 1 times w gives me minus w, and minus 1 times minus 5 gives me plus 5. Now to actually work out what the answer is going to be, the bits on the outside, so I've got 3w and minus 1, that makes one bracket, and the bracket that repeats itself is my other bracket. So this is what that factorises to. Now I said I would explain why I wrote it this way round, and it's because I'm used to this method. I know I'm going to factorise, and therefore it makes sense to me to have 15 on this side, because I know for sure that 3 and 15 will factorise. If I wrote it the other way round, 3w squared minus w minus 15w plus 5, that could very well work, but it might not. Okay, so you're trying to make it in a way that it will definitely factorise. Okay, if it didn't work, so for example, this bit here should be the same on both sides. If I put that on the other side, and actually I couldn't think of a term that could give me this part, then you could switch these around and try it the other way round. But generally, if you just make sure that it looks like it's going to factorise, it's going to work. Okay, so I need to remember this bit, all right, because that is the same as this now, because I factorised it. So we've taken our answer from before, and we're now multiplying it by this. Okay, so I'm going to write it down on my next line. So 2 over w minus 5, w plus 1, and I'm multiplying it, remember, that bit is only up to here, multiply it by what I've just factorised, which was 3w minus 1, w minus 5, okay. Now, this is the same as saying 3w minus 1 over 5 over 1. Okay, I really want to make sure that these are both fractions, because then I can use my trick. Alright, so, a number like 5 is the same as 5 over 1, so this is the same as this over 1. Okay, because if I divide it by 1, I'll get that. So now I can then see, well, okay, if I look at the opposite sides, we've got w minus 5 and w minus 5. So I can cancel through by dividing both sides by w minus 5. If I now look at the other way around, I can't really do anything. I can divide it by 1, but that's not going to help. So that's the best I can do. So if I then write down what I have left, I've got 2 times this, and then I've got w plus 1 times 1, so it's just w plus 1. Okay, and then if I just get rid of these brackets, because in the answer I don't want the brackets in, as you can see, I get 6w minus 2 over w plus 1. Okay, that is now in the form what I wanted. I wanted a number in front of w, so that's 6. I wanted the plus b. Now, if it says plus b, it doesn't necessarily mean that the answer has to be positive. Okay, it just means that you've got AW add another thing, and it just so happens that the bit I'm adding on is a minus, so it's minus 2, so that's fine, don't get confused by that bit. And then we've got a number in front of w, so in this case it's 1, because it's 1w, plus d, and in this case the sign is the same. Okay, we just check with what it says in the mark scheme. Okay, again you can just see it's just a mark, 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 mark. There's no dependent marks, so the examiner is just simply looking for these bits stated. Okay, so have they done w plus 5, w minus 5? Okay, yes, we did it here. So that's 1 mark. Have they done this bit, w plus 1, w plus 2? So that was when we factorised that bit there, so we've done that. The next bit, right, if they put 3w plus something, okay, or w plus something, as long as it matches these rules, so the a plus b has to multiply to make 5, or the a plus 3 lots of b has to make minus 16, they will give you the mark. But you get 2 marks if you just get to this stage. So 3w minus 1, w minus 5, like what we factorised to, that is going to give you 2 marks, because quite clearly if you can do that stage, then that bit's going to be correct too. So that's give you 2 marks for that bit, you get those 2 marks, and then to get the final answer, 6w minus 2 plus 1, then we can see then that's correct.